So let's work on the square and multiply algorithm. And the idea is to do fast exponentiation of numbers. You can see, let's do an example. I think it's the best to understand how it works. So we will have the, let's call it a normal part and a modular part if we are working in a modular environment like a finite set. So let's start with normal without modulo. Let's start to take the exponentiation using the square and multiply algorithm of 7 to the power of 20. So I will convert the exponent to binary. This is the first thing I do. So 20 in binary is 10100, 2 to the power of 012, which is 4, 2 to the power of 01234, which is 16. 16 plus 4 is 20. This is the binary representation of 20. Now, how will I do the exponentiation? I will use this binary representation right over here, 10100, and whenever there will be 1, I will do square and multiply of the number. And whenever there will be 0, I will just square the number. So we start. Take 7. Take 1. What I said 7. We are starting with 1 and square it and then multiply by 7. This will give you 7. Take the result and the other bit is 0, so you will just square it, so it's 49. The other bit is 1, so we will square and multiply by 7. So the result is 49, so we take it and square 49 to the power of 2, and then you multiply by 7. 7 is our base. So this is the result, this is the value. Next bit is 0. We will just square. Take the result and square. Get the result. Continue. The next bit is 0. The next bit is 0. So just square the result. Take the result from the other previous and just square it. This is the result. And this is the process to take the 7 to the power of 20. Now we can also do it in a modular representation. For example, what is the modular representation? What is the value of 7 to the power of 20 in modular representation mode 100? Let's try it. Again, we take 20 and convert it to the binary representation, which again is 10100, as we saw last time. But now our calculations will be mode 100. Let's see how it works. We start with 1. So square and multiply because it is 1. When it is 0, just square. When it is 1, square and multiply. When it is 0, just square. When it is 0, just square. Let's start. Square and multiply. Take 1, take it to the power of 2, and multiply by 7, and take it to the mode of 100. We'll get here 7, mode 100, which is 7. Take the result, and we have bit, which is now 0, so just square it. So 7 to the power of 2, which is 49, mode 100 is still 49. The next bit is 1 in the representation of 20 in binary, so we need to square and multiply. So take the result from the previous part and square it, and then multiply, and then take mode 100. You will get 43. The next bit is 0, so we will just square it. So take 43 and square it. All of this to the power of 100, or to the mode of 100. Again, you will get 49. The next bit again is 0, so we'll just square the previous result, getting 49 to the power of 2, mode 100, which will give us 1. So the final result of 7 to the power of 20 mode 100 is 1. So we saw how we did it in a normal, let's say, real numbers. how we did the exponentiation by converting the exponent to binary and using the bits to know if to square or multiply the previous result. And you saw how we did it in a final set, in a modulo calculation, and we did the same, and the same idea, convert the exponent to binary, and if it's 1, and move from left to right, and if it's 1, square and multiply, if it's 0, just square. So we always square, but when there is a bit of 1, we also multiply, and we take every time the previous result, and you saw how we get the result. So this is an algorithm for efficient exponentiation. Thank you very much. If there are any mistakes, hallucinations, or something, please correct me, and that's it.